All right, guys. Testing the sound. We sound good. Well, I don't sound good. Lost my voice. Been a tough, long few days, I'm sure, for all of you. So thanks for coming out to listen to this talk. I want to just say up front to everybody that the talk is specifically going to be about downstream separation, right? So I was having a look through the app, and it spoke more, excuse me, more broadly about yard of the future, etc. I like to just let everybody know up front that we're speaking to probably two of the best in the business, one specifically on waste and MRF separation, and the other one will be talking about downstream metal separation. So I just wanted to let you know up front, so that if you thought it was something else, you have the ability to walk out if that isn't something that you were signing up for. I don't want to waste anybody's time. But on that topic, I think there is absolutely no doubt in my mind from the meetings that we've had before this, the conversations that we've had, that we do have two of the best in the business, Schon and Ferdinand. The way we're going to roll this out is, before we open up for questions and we start really getting to know them a bit better, we're going to allow them both to give us more information on exactly what their company does, some examples, and when they started and who they are and things like that. So if I can start with Schon, let's move over to you from AMP and run us through what you guys do.
Perfect. How's my audio? Good?
You're amazing, mate.
Perfect. So AMP, some of us might be familiar with AMP through the years. We've been around about 12 years, and we started out as a robot company, sort of cleaning up things in mostly MRFs. And so we might be familiar with about 400 robots at 300 sites in 12 different countries and 3 continents. 2 years ago, we made a shift to design, build, operate, maintain full facilities. So instead of seeing a equipment company, then a different operator, and then managing the offtakes, maybe through 2 or 3 different entities, we're sole sourcing all of that for our clients. And so what we'll talk about today is really the opportunity that resides in MSW. The volume of municipal solid waste that's out there is tremendous, and there's a total amount of value that's in there. We're going to talk about a project that we've been doing the past 2 years for one of the municipalities here in the States, diverting binds for them, and really what those outcomes really help. But if we think about the actual volume, there's literally a ton of value that's getting thrown out in our trash. Source separation is great, continues to grow, but the real key to changing our recycling here in the U.S. and throughout the world is getting material out of our MSW. And there's 2 negatives that I think I've heard and seen often. One is you can't sort MSW at scale, and 2, when you do it, you're still left with a pile of crap that you can't go sell. So we'll talk through how we're getting value out of sorting MSW. So the recycling partnership in 2025 said 3/4 of recyclables in the U.S. are thrown out in the trash. And I think about myself. I go to the airport. I had my Starbucks cup. I had my ice in it. And I'm thinking, all right, I didn't know well enough, and I'm going to put that in with my trash. And for most of us, the source of I don't know ends up being the trash. And if I don't know and there's multiple containers or even one container, most often I end up throwing it in the wrong place. And that's pretty much most folks' habits. If we think about what's changing in this space, if we're in the UK, we have an emissions trading scheme that's kicking in January 1st, 2028. So there's a carbon tax that's going to come into play. In certain municipalities like Spokane, Washington, the carbon tax is already in place. So there's regulatory and tax focuses that are coming into play. If we're in the UAE, there's Vision 2031. If we're in the UK, less than 10% can be landfilled in the UK after 2030. So there's a lot of movement around diverting materials away from disposal through regulatory action as well as in incentives. If we think about our landfills, part of the U.S., there's no issue. If we're in the state of Arizona, there's over 40 landfills, plenty of capacity, no issue. But here in other parts of the country, maybe California, maybe New York, maybe the Northeast, we're running out of space. And the regulators don't want to open up new landfills, or there physically isn't room to put in a new landfill. If we think about the carbon market, notwithstanding the news last week from one of the Fortune 10 companies, there's still a carbon market that's going to be developed. It's early, but it's not far along. We'll talk about what we've done with Google. If we think about really what AMP has done with our neural network, over 200 billion different items that we've seen with our camera eyes, which is the same as our human eyes, we can actually identify what things are at scale, moving at 700 feet per minute, identifying individual things at a container level and understanding what they are and then diverting it. And really developing new models. We've gone down the path with SIPSA, and we have a couple others in the project going as well. So if we think about AMP, we talked about this already. Keep going. And so really what we've done is we've developed the first MRF that is managing MSW here in the States. I've seen other facilities in Europe that actually do it, but it's at a much smaller scale, or the facilities is much bigger. The biggest part for us is the size, 15, 25, 50 ton per hour units that can manage different volumes, different materials, but actually fit it in a 10,000 square foot area. So it's not like we need a big building to put this facility into. The MRFs I've visited, they tend to have 70, 80 people per shift. We have 10 people per shift. From a capital perspective, it's about a quarter of the cost. From an operating expense, it's about a fourth of the cost. So easy operation, simple for us to do, significant uptime. We had a ribbon cutting last week. The facility went down in the middle of a ribbon cutting, which is never what you want to have happen. So we're walking around with the clients and the elected officials, and the plant goes down. 5 minutes later, it's back up. So you have to manage through those, but you still can't be 100% uptime. From a capacity standpoint, I mentioned 50 ton per hour as the biggest unit. We'll just put multiples in parallel to each other to get to that 1,000,000+ tons per year. So we're working on opportunities to create SAF, RDF, SRF, as well as making recyclables here in the States. So from a build-out perspective, most often it's a brownfield location. Somebody has a transfer station, big tip floor. We just put in the actual equipment within that existing tip floor location. Very seldom do we have to look at building a new building. We have one input with MSW as a feedstock, and we'll have 3 different outputs. One is your residue that's going to still go to a landfill. The others are the recyclables, and then the last one is your organics. It's a little bit interesting to think about how much the organics is actually in the trash. It's about 40%. It's not insignificant here in the States. So we'll talk about a case study here. So there was a waste energy facility in Virginia that needed to close. They lost one of the revenue streams of the steam, and the facility needed to close. That facility was taking all of this waste authority's volume. It was 8-member communities, 1.2 million people, 600, 700,000 tons per year of waste. The authority owned their own landfill. So now instead of just disposing of the ash, they had actually disposed of 100% in the landfill, which meant the landfill was going to close in 2060. They went out and looked at what are our options here to sort so we don't have to dispose of everything. And so we built, I'm getting ahead of myself a little bit. We ended up building a plant at a sister location that was already servicing the authority, and went through a pilot for them. If we think about what the goals were for the authority, they wanted less waste going to the landfill. They wanted a significant change in how long that would be there. There was a forward-thinking director, and they said, well, I don't want to have this plant close, and then I want to get it open till 2100. They wanted to really reduce the amount of trucks on the road. They see a benefit in that we can build those plants really close to where the waste is generated. They wanted to increase what's happening with the actual recyclables in the trash stream. And so they also wanted to look at what they were doing with the organics. So we're building a biochar facility, have a pilot biochar plant already open in Portsmouth, and we've already sold those carbon offtakes to Google. So a great opportunity for that authority to change the economics as well as the material going to the facility for disposal. And the biggest part that they were really looking at is flexibility. The waste stream is going to change. Our inbound waste changes week to week, month to month. Easter is different than Christmas. Various holidays are various changes in volumes. Halloween different as well. So if we think about flexibility today and tomorrow, human eyes, RGB cameras, they can easily see what's different, what's the same, and identify which way we want to sort those materials. We'll talk through some of the performance metrics that we've done. So we designed a facility within the footprint of the authority. We own that building now. We had the pilot for 2 years. We're managing only about 30,000 tons per year. And in the end, we were diverting 58% of the material from disposal. They went out to RFP. We were awarded through that RFP cycle. Multiple different diverting companies bid in that process. And we have a 450,000 ton per year requirement to manage. It might be as much as 600 to 650,000 ton per year. Acceptance testing in January, we came in at 73% diversion over those 3 days. So our contract requires 50% diversion. We contract diversion, we contract throughput, and then we also contract uptime. And if we don't hit those goals, we have to pay back the authority. So we put our money's where our mouth is. We're not like just saying we're going to hit it once at acceptance. We have to operate to those parameters and exceed them. So these are the inbound feedstock. What would you see on the left is your normal MSW, what you're going to see from all the different components you would expect. And then on the right side is what we're seeing on the offtake side. Mostly it is the organics. Then you start getting into the recyclables, and then you're just left with about 0.25% of the revenue, or 25% of residue. Those recyclable offtakes, we're selling them to the same provider you would sell out of a MRF. It's not that we don't hit his respec. We get a lot of UBC, really strong UBC partner, and we're selling the same materials to the same people. When it's dirty, the nice part about paper and fiber and OCC, when it's dirty, the eye see it as dirty and it puts it in with the biochar. And so it's mixed with the organics and turned into biochar. So the contamination part we address with our eyes and diversion into residue or into with the organics. The biochar is sort of the makeup of it, whether it's mixed paper or actual organics and other material. So think about the sortation process as you have an initial process that will take out the fines, which is primarily organics. You're going to also go through and take out your metals. You're going to take out some things that would clog the system, like long textiles, like think about runners that would wrap around conveyors. We're going to quality control those out early. So the first sort is going to be taking what would be your classic single stream recyclables and separate that from your residue. Your single stream, then we take that downstream like a normal MRF and would separate those using the same AI processes into your OCC, various plastics. Then the organic stream, the fines, it's contaminated. We clean that up again so we can hit compost, AD, in this case, biochar specs. So it's really 3 different separation processes within one big plant. So here's the Google announcement. Google is really ecstatic to buy the 200,000 ton credit, and that goes through the first 5 years. It's really early. The news last week wasn't helpful from another one of the companies, but this carbon market adds value so that in this case we generate revenue and it lowers our costs to the municipality. It's a really nice way to generate carbon credits. The biochar that we create today will be used as an alternative daily cover for the first 3 years for the authority. And then after that, we'll sell that to a third-party partner who will use it as a way to become carbon positive rather than a carbon negative entity. And then future regulations, we talked about diversion and adaptable end product optimization. So we might be on the Iberian Peninsula. They want the customer may want to generate RDF or SRF. We can simply divert 85% for an RDF SRF spec. So the end product optimization really doesn't matter what the output needs to be. We can configure the neural network to set it up that way. Low risk funding in the case with the authority was our capital that we put up. So the company, or in this case, the municipality, didn't have to put up funding for that project. It was announced that bigger than it really is, but it's still a significant project. So from a funding perspective, it's not like somebody has to put up the money. AMP will do it ourselves. Some of the news over the past year and a half, whether it was time or some of the other announcements that happened, Fox was there for some cut-ins on a live day. So it's interesting being out and sorting MSW. I can think of a couple of other places it's happening, but it's close to first of its kind here in the States. It is first of its kind here in the States. A lot of folks have done an attempt at dirty MRFs. And if you think about the waste majors, a lot of local regional firms, dirty MRFs are really hard to do with people hand sorting. And any of us who want to do that job for about 20 minutes, or anybody wants to do that job for about 20 minutes. So it's really cost intensive, doesn't do it at scale, and doesn't really cost well. So this outcome with the neural network, the ability to sort, we were in the point with robots doing about 300, 400 picks a minute. We're around 5,000, 6,000 picks a unit now. And so picks per minute. So we've definitely scaled it up and be able to manage at high volumes. We're working on a 5,000 ton per day opportunity right now in Mexico where they would make SRF out of it. I'm sorry, SAF, Sustainable Aviation Fuel. That's sort of the AMP. I sped through it, so we have more time about questions as we go. So I'll hand it over to Ferdinand.
Thanks, John. That was awesome. I said earlier, I think we've got the right people on stage. I think that backed it up quite nicely.
Thank you.
Ferdinand from Binder+Co.
Okay. Thank you, everybody, for being here in the ReMA overtime and listening to our little talk here. And so my name is Ferdinand Schon. I am with Binder+Co. The company is based out of Austria. So we are headquartered about 2 hours south of Vienna, and we have a subsidiary in Louisville, Colorado, where we handle our U.S. customer base. Myself, I'm actually living in Dallas, Texas, as you might hear from my Texas accent.
Mine also.
I always say I'm from Far East Texas, if somebody asks me. So we have a pretty wide product portfolio from crushing, screening, wet processing, drying, cooling, sensor-based sorting, as well as packaging and palletizing equipment. For metals recycling, we mainly concentrate on our screens and our sorters. Many of you might be knowing our equipment without knowing us, because the pivot tech is our original design, which we have been marketing and manufacturing through our licensing partner AEI in the US since sometime in the 80s. Other than that, we are active in primary raw materials, aggregates, minerals, mining, as well as all kinds of recycling, from glass recycling, obviously metals, as well as C&D, compost, and several other things. So today I want to concentrate on AI technology in metals recycling. And so first, to get to the definition, what does it really mean in when I talk about AI sorting? So what I mean there is using the base of a optical sorter, and then with a AI module to dramatically enhance the capabilities of the optical sorting machine. And so that enables us to handle a wide variety of materials, obviously sorber, twitch, but also something more like with zinc and Zurich, as well as on the e-scrap side, wire chops, stainless, ASR, heavies, and even down to IBA if necessary. So the AI sorting that we provide can be put on the platform of a chute sorter as well as a belt sorter, and it comes with different designs and sorting this from 700 millimeter to 2.1 meter, or like 7 feet wide, and depending on the application, reaching throughput rates of over 20 tons per hour. So I guess the question is what applications can be covered with artificial intelligence sorting, and the basic answer is anything that the human eye can distinguish. We can teach the machine to learn that process and do the same operation. And to make that visual, you see here a mix of ASR heavies. And now you might be saying, okay, I can just use my conventional optical sorter and get a copper or brass fraction out of that. And that is certainly true. But the AI machine can do a lot more than that. So first of all, you can also recognize copper or brass that is coated or very dirty, and the machine will still be able to distinguish it as copper and brass and sort it accordingly. Or if you want to pick out screws, you want to recover these, you can do that, because the machine will know the difference between a screw and another kind of scrap piece. And so that comes very handily also at e-scrap applications, because the AI technology is very good in recognizing PCBs and in separated from other green plastics or obviously also different color PCBs if you teach them in correctly. And then you can also, because the AI technology looks at color, shapes, surface structures, any visual information, so you can easily pick out ICW and any shapes or sizes. So there's a lot of versatility. Back to the scrap side. So another application would be from eddy current drops and then separating into stainless and ICW to create a clean stainless product, for example. And now, of course, probably most applications we see in the main scrap, non-ferrous scrap, is in upgrading sorber, taking out reds and yellows out of sorber, as well as then separating cast and wrought, and so helping to create the new Vespa product. And then we can go even further than that and take out extrusion pieces out of sorber or twitch, and so create a clean extrusion package without having to go to very sophisticated sorting technologies that are much more expensive. And here we're going back to an example that hopefully illustrates the advantages of AI sorting compared to conventional color sorting. So it doesn't matter if the copper doesn't really look much like copper anymore, but the machine is still able to recognize that. Similar on the brass if it's coated, and has no problem distinguishing PCB versus a painted aluminum piece or something like that. So in this example from a mixed material stream, it was the challenge to create a clean gray metal product while separating out any copper, brass, and other materials. And now to conclude my introduction, a little video that we have compiled on our first sorter in the US. Kind of material.
Looking at a solution to some of my recycling issues was sorting alloys and sorting out aluminum and copper. Vendor offered us the opportunity to collaborate on a new kind of machine that involved AI. And we have had major improvements on the type of material that we're able to get out of the machine and the cleanliness of the material coming out. Sorting out cast from wrought was very unique, and it expanded the capabilities of this machine much more than we ever thought it could. So I've been a very, very happy customer.
Okay, thank you.
Thanks, Ferdinand. Becky Prola, it's pretty impressive. If any of you guys know Becky Prola, there's some nodding of some heads. That firstly, it's hard to get her on a camera to tell somebody how.
It was a challenge.
It was a challenge, I'm sure, but Wow, that's pretty
No, but she
impressive.
did a great job.
Pardon me?
She did a great job.
Well, she did a great job. You're obviously doing a great job if you convinced her to talk about how good your equipment.
But it was more the machine that convinced her.
Yeah, no, that's phenomenal. Let's jump into it. I firstly want to say, guys, we will at the end try open up for some questions. So as we're going, if something crosses your mind and you want to ask something specific to the two gents, there'll be microphones on the outsides. So just plan some questions if you have any. You've both made some pretty impressive claims, backed up nicely with Becky. But really some big things have been said. You know, AMP, you're saying $270 billion in recyclable metal gets buried in landfills every year. That's a big number. Binder+Co, Ferdinand, you know, you say we process the future. What is the single biggest inefficiency in today's recycling operation that your technology solves? I think it's pretty obvious, but if you can run us through it. And then in one sentence, what does the yard of the future actually look like to you guys? Start with you, John.
I think it's cracking the code on MSW. We will continue to source separate and have more containers, but figuring out how to sort materials out of our trash stream. And I think the facility of tomorrow has more and more technology like we saw with Binder, like we see with AMP, that does the heart and soul, but that there's people running it. I think that's both the plan of today and the plan of tomorrow.
I think, John, on your side of things with MSW, it is just so vital because the effort a lot of people make in their households to recycle and put them, a lot of that doesn't even get recycled properly. And I've been living in New Zealand for 10 years and they've done a lot of studies and, people tested the system and found that even that material wasn't recycled. So we have to understand that it's not actually happening anywhere close to as well as it could. And if you can stop it at the MSW level, that's actually solving a huge problem for all of us.
No doubt. There needs to be more policy around, especially plastics. If we think about the PET market, we think about other problems that you can go buy brand new inbound chemical cheaper than you can on recyclable materials. We need a little bit of help from a policy perspective to help drive that as well. It's not just simply the technology or the companies. There needs to be some better policies. We can buy virgin plastic too often from other parts of the world that really impact. It doesn't matter where. When we were in Europe at one point a couple months ago, some of our tariffs basically flooded the European markets with virgin plastic because it couldn't get sold here at the same price like it could be sold over there. And so there's a lot of plastic capacity from a recycling perspective. A couple million tons per year went away last year in the EU.
Yes, well, Ferdinand?
So how can AI help with the recycling? And so what I would say is that specifically for metal recyclers, many people are creating Sorber. That's kind of a go-to product. But then going the next step and upgrading that to Twitch, Vespa, and then more specific materials is a big step for many yards. And I think that's especially where AI sort of can help because it lowers the investment costs. It makes it much easier to get to that point where you can get an supreme product and get a higher value out of this guy.
You made a claim that Clarity AI can basically see the exact same as a human eye can. Before I ask you a question, I want to tell you, 28 years ago, I started working in the metal recycling industry, and I started in a small yard in KwaZulu-Natal, which is near Durban, and I was blown away, not just by the ability of what metal recycling can do, but the guy who trained me on non-ferrous sorting was blind. It's a true story. And he was able to hear the metal by pinging it with a piece of steel. He actually did the buying on the front scale. That's a true story. He would literally sit there and he had a little piece, like a little stick, and every time something came in, he'd ping it and he'd go brass. He'd ping it, he'd go copper. Ping it, he'd go aluminum. It was absolutely wild. But you're dealing with some of the dirtiest streams, right? You're talking about ASR you guys are handling as well. Where has Clarity even surprised your own team?
I would say in the development process almost every day. I mean, so we started out 3 or 4 years, and the first application we looked at was separating black asphalt pieces from black rock. And so we could, using the surface recognition of the AI technology, to make that work. And since then we have expanded and finding new applications all the time. And so another big step, of course, then is like the cast from rod sorting. You don't have to do that with an XRT machine. You can do that with AI as well. So and then maybe talking about heavies and separating zinc from aluminum, which really looks very similar. But the AI machine is also capable of doing that. So these are probably some examples.
I mean, you guys probably experience every day what I experienced the first time we put an eddy current in, and it was like, what is the sorcery, right? Everything coming, all of a sudden, materials just pinging off. You knew it was there, but it was just like magic. And you're obviously seeing on a daily basis new material that you're testing, which is pretty awesome. You use 4 sensors, right? So you have different sensors simultaneously. What does combining all those 4 sensors change, I guess, compared to single sensor systems?
I mean, and so that's not really that different an approach compared to other sensors that have been out there, or other sorting equipment. It's just the more sensors you have, the more information you get on a certain particle, and the easier it is to group it into a specific material class. Now, what we're actually trying, especially on the scrap side, is to reduce the sensors to be used. So for scrap, we mainly rely on just the optical camera, and in cooperation with the AI module that gives us enough information to really handle all these sorting tasks. So we don't have to go to the 4 sensors, because that then adds more cost if you do that. And that's what we're trying to get down. We want to lower the investment and make it easier. Of course, if you look at like e-scrap, you might need to add an induction sensor, so that the machine will know if it's metal or plastic, and then that will increase the sorting efficiency. But in general, we try to go with as few sensors as possible.
Ferdinand, I'm going to stick with you because we both live in Texas. I live in Austin, so people just get used to our Texas accents, and they don't have to keep bringing in John's, crazy accent that he has here. So, you now live in Colorado, I think?
No, in Dallas.
Oh, so you live in Dallas. So exactly. We're both from Texas. So what are you finding differently when you're in the US compared to being in Europe? When you're going in and doing samples, is there a difference in material that you're running? When you arrived, maybe it was new. When we started Buddy Tech, we came in, we thought everybody was going to sell CFR. We found out pretty much the whole American market sells FAS. We had to kind of change a little bit of our model. Have you found anything different?
Yeah, I mean, caveat first. So, I mean, I'm working for an Austin-based company, but I've been living in the US for such a long time, and I really got into the business here. So I know the American scrap market much better than the European market. And I mean, I know a few differences, but I'm not an expert on the European market. I know it's a little different approach, and there are different materials, probably not as focused on Sorba, Twitch, Vespers as they are in the US here. But so that's also the advantage of having a machine like the AI sorter, because you can use it for so many different materials. So it's not really that important if your market is a little different, because the machine can be taught, and a different program used for a different material. So it's very flexible.
The 3 most important letters that I learned when I was running operations 85 yards was return on investment, ROI. So if I was to ask Becky or a couple of your clients, what is the real return on investment? What's that period like? Like, how long is it going to take me to get my money back if I bring in clarity?
Yeah, and that's the big advantage with a machine that's based on optical sorting, because it's a slower investment, and you're definitely talking in ROI of months, not years. So definitely under a year is more than possible.
That's impressive. When we buy capital at the moment, we're all talking in years. So, John, maybe I won't ask you that right now, but what's your ROI like?
For most of our clients, because tip fees on the West Coast, East Coast are higher than our price, it's instant. It's not like any time. And so they're immediately getting a buyback. And it really comes down to who's managing the offtakes, if it's their capital or our capital. But the client in Pennsylvania or in Virginia is saving money immediately. And they're actually getting charged less now for their MSW than they were on their recyclable. So the MRF was charging them more than what we're charging them now for the trash.
You spoke about being able to handle different size operations, right? You know, in your honest opinion, I guess, where is that sweet spot in terms of volume, footprint, capital commitment?
It depends on the community, on what the feedstock is. You really can't control the feedstock. Feedstock is what it is. If you're in a big city, Austin or Dallas, there's going to be a lot more volume than it will be in Laredo, right? And so it really comes down to, you want to size it generally between 100,000 and 500,000 tons per year. When you get into the 1 million plus, you're probably going to be doing it across multiple locations. To go build a 5,000 ton per day, 2 million ton per year facility, that's going to be that one we're working on multiple 100 ton per hour lines. That's going to be a pretty big uptick and a pretty expensive plant in and of itself. But anything below 65,000 ton per year, we have a couple opportunities in the 35 to 50,000 ton per year to clean up like an olefin feedstock or clean up another plastic material so they can do chemical recycling. That's really the smallest ones. And once you get below that 50,000 ton per year, the just overall operation and capital, unless you can get a good price on that offtake, it really isn't helpful.
That case study was pretty impressive. The Virginia one, I want to just use some of the stats. You said 73% diversion, 92.5% uptime, 98% targeted item recovery on 450,000 tons per year. All right. That's impressive. What would have killed that project if you hadn't solved it? And what was the hardest thing to get right?
I think having a diversion goal that was realistic with the authority. We have a 50% diversion rate in the contract. And if you overcommit on that, that's sort of like the biggest risk. You can't control the feedstock. There's 8 different communities, Virginia Beach, more touristy, higher quality recyclables in the trash, all the way in through some towns like Norfolk and Portsmouth, where there's a variable recycling rate, and a town like Chesapeake that might not even have a single stream. And then you have your more rural communities where there's a varied amount of recycling. So it's just interesting as you think about the feedstock, you just can't control it. And you have to be able to commit yourself to a reasonable number. And that's why hitting that 73% was great, because we knew we had so much flexibility. But if we had committed something in the 65% range, that authority director, they were at the first day sweating bullets. First of a kind, somebody stuck their neck out, pretty much walked their plank on their career to really stake on something first of its kind, and to see Dennis there that day, almost sweating bullets figuratively, and then 2 hours into it, seeing the numbers rolling in, he didn't come back Wednesday, Thursday that week. So that really helped get over the hump there on the whole acceptance side. The targeting thought, like to be actually be able to see, similar to Ferdinand's, if you see it up front, and then the cameras are so darn cheap, you put a quality control on the backside, so you can see what you're actually diverting on the front end and a quality control on the back end, and get to that 98% diversion and the targeting rate. That's a significant change too. And when you see that targeting rate go down, somebody working in the neural network to change, hey, we're missing on UBC right now, we're missing on clean fiber, we're missing on something. And that's sort of the circle in the box. The box is AI, and the bot, you always have a circle. There are 5 people full time just double checking the bot, because you can't just let that thing run on its own. You have to have a human in the box.
Question. The human is kind of the way of the future, right? It's vital that we see it like that. I see there's a question.
Yeah, I do. Just because you're talking about capital and ROI, and you're talking about the ability of AI, and I should preface this that I'm in charge of HR for my company. And so part of my job is trying to think about the workforce of tomorrow. And so when you're, one thing is about material recovery and streamlining processes and increasing the return from that aspect. But I'm assuming that when you talk about having the same ability to sort as the human eye, then the implication is that would be replacing the human that's currently doing the sorting. And so I just have two questions, and I apologize. Maybe you're addressing this in a future question. But number one, which is the key, have there been any studies, or maybe it's just too early with the technology as far as the capital savings? Because of course everybody's struggling with the labor market and immigration being what it is in the United States. And so having those pickers, those sorters is always a challenge, and that's usually where the turnover is in most of the companies. So have there been any studies of the cost savings of the customers that have used your technology as far as labor savings, or even savings as far as injuries? And which is the first question. The second question is, to run your equipment, obviously, there's also the factor of the training and the skill set for the people that are going to be in the box, as you describe. What is the learning curve? Is there some sort of training program? What have you found are the skills that those people need to be able to work this technology compared to who we have operating in our yards now?
I'll open up to you guys. I just want to kind of delve quickly into number one, if that's okay. Question number one is, how many people are we replacing? I think if you look at both of their processes, currently it's going to landfill. So you're not actually picking out a lot of that material. And Ferdinand's actually sorting further downstream. So the material could be sold as Zorba, or you can continually upgrade it. So that's not necessarily replacing people. It's optimizing your process. Through equipment, you're using equipment currently, it's kind of putting on further downstream and further sortation. Do you guys agree with that, or is there anything you want to add to that?
I think that's salient. The first part for us is really divided into two subsets. We're operating MSW, which would be net new, to Sue's point. So we're not displacing people, we're actually adding jobs. And so maybe 10, 12 people per shift per 250,000 tons per year. Net new addition in jobs. If we think about related to MRF, we are building a MRF with Waste Connections right now outside of Denver and Commerce City. I think that will present a lot of case studies around what Waste Connections does at all their other MRFs, and probably all what Waste Connections will hold close to vest on it. But then the value that we bring as to operating costs, as well as the recycling rate increase they see with us operating at their MRF. So I think there will be more information related to that. And I'll keep going on number one before we go to number two. I'll keep it that.
Someone had a facility in Colorado. I couldn't remember it.
Well, and we're Louisville too. So it's the funniest world where both of our headquarters are in the same darn town.
Yeah. Did you have anything to say on number one, or should we jump into number two?
No, I think I can agree with that point. Typically, it's an upgrade, so you're not taking a lot of jobs away. You might be adding jobs. On the other hand, what I'm hearing that it's often very hard for the recyclers to find the people that want to do the hand picking. So they would rather automate that and put these people in other jobs that they probably appreciate more.
Yeah. On number two, which was around training, do you guys want to talk about your specific system around how training works?
Yeah, and that's another point for the AI is, so for the actual operator, it's not really any different compared to an conventional optical sorter. So you have the programs in the system, and the only thing the operator needs to do is push the button for the correct program and then run the material. So very similar to a regular optical sorter. The only difference is in the setup of the machine and adding programs, which is a little more difficult compared to an optical sorter, but not that much. We need like 1,000, 2,000 pieces of each material, run it over the machine. And so we would be doing that, or our technicians would be doing that with the customer. So there's really not any more learning curve involved on the recycler side.
Happy with that? Beautiful. Look, I'm the famous Cozy family are now going to ask a question as well, but usually we wait the questions to the end. I'm happy to mix it up, make my job a lot easier. I can stop asking questions. If anybody has questions as we go, feel free to jump up to the mic and let's jump over to Albert.
Question for Ferdinand. You mentioned ROI or a payback period of months, not years on the equipment. What type of volumes are necessary to achieve that?
I mean, as you know, I think that that is a challenging question because you can have a smaller machine and a lower volume. You can have a bigger machine and a higher volume. I mean, yeah, in general, probably you can get a little faster ROI if you have a bigger machine and you run 15 or 20 tons an hour compared to if you only run 5 tons an hour and have a smaller machine. And that's pretty typical. But so the tendency, I would say, goes if you have a bigger machine and higher throughput, then your ROI will probably be a bit shorter than if you have a smaller machine and a lower throughput.
All right, back to me. 200 billion. You guys can recognize, is that 200 billion different pieces of metal? Is that right? Or different pieces of material?
Yeah, it's over 210 billion items we've recognized through our history and growing. It's a couple million basically a day.
So in Europe, if somebody is using the equipment, is that actually training the same system that we're using in the US? So the more going through Europe, you're adding up to 210 billion. It's going to be 300 soon, and it doesn't matter where that is in the world.
Exactly. So the Attero facility in Western Netherlands, they're using multiple robots, and we're seeing the PET, the HDPE notch with all the different inputs and cleaning it up for them with our bots, where we started. And that data goes into the neural network. And if we see that same item in Denver, Colorado, we'll recognize it. So it just continues to feed upon itself. The AI is going to say, I predict that to be 88% this. I predict it to be 54% that. It actually tells you, like, not only what it thinks it is, what its percent probability is, what its surface area, what its weight is, so that when it goes downstream and we want to divert it, the right kilopascals of pressure across one or multiple nozzles will blow when it's physically there and divert it when we want to positively target something. So yes, the neural network is it's one organism that understands all that we've seen.
And you don't sell your equipment?
No.
You literally operate the system yourself?
I've had to say no a lot lately because of the sort of the announcement with the authority and also the Google announcement has driven a lot of activity and no's been an uncomfortable but a common word lately.
Talk us through the commercial terms. And I mean, how does this work? You put your equipment on somebody's site. Do you then pay them for the offtake? I mean, what happens?
It all depends, really. There's two variables for our clients. What offtakes are they taking or are we taking? And in the authority in Virginia, they have the landfill. They're taking the residue. We take everything else. And so as the commodity market goes up and down, it's a risk on us. We've made an agreement that says, hey, if it's below a certain number, we're going to start billing. If all of a sudden the market went through the floor, there's a floor in the contract, and then there's a ceiling. The markets all of a sudden explode. We're going to start sharing revenue as it does go up. So the client chooses what they want to take, and in some cases it could be none. Like we have a project in Poland that's going to start soon, and in that case we take nothing. We're just operating the box. We have parameters that we have to hit in diversion, in uptime, and throughput, and those are all contractually required. But when it comes down to the capital, that's a second part of the equation. The client in Poland, it's their capital. The client in Waste Connections was their capital, but the client in Virginia was ours.
Let's talk about carbon credits. How does this actually benefit a recycler today? Talk me through the revenue process, right? So how that actually works, how you guys assist in that. I mean, obviously, big announcements, very exciting. Surely everybody's excited about this and interested to know more. Can you just kind of give us a practical understanding of how it brings in revenue, how you guys participate in the whole process?
So the first step, and I'm not a carbon expert, I know enough to start the surface and sort of share it. But if you think about it, you have to have a way to convey that what you're doing is sequestering carbon. And so you have consultants that you've hired, that the offtake provider is going to go buy your credits, are going to look at what you do and how you manage it, and they're going to certify that yes or no, that what you're doing is sequestering carbon. Then from there, there's a market that's burgeoning. You're going to find a partner. It tends to be one of the Fortune 10 companies that may or may not be operating data centers, because those are the ones who are out in front of things. And that's the quick ecosystem of setting up carbon credits. Is probably a tenuous process to get credit that you are sequestering. And then you're going to, in this early phase, you're getting paid a price per ton. That price per ton, as this evolves, should quadruple over time. So it'll be another benefit. And it really, in this case, was a way to, you expected, you thought that you'd be positive that you'd be able to go sell carbon credits, but it wasn't baked into the proposal. And it ended up being like, let's go lean on the first of its kind. And then from there, you can say, all right, that's accretive after you've gotten the award and you've gotten the announcement. So, it's, I think as we go forward, whether it's you here, there's going to be more opportunity to sell carbon credits.
I'm hearing a lot about carbon credits lately in general. There's a lot of opportunity for larger metal recyclers to actually get involved in that. So, and recyclers in general. What about data? Everybody, we have a platform, and we get asked constantly about, well, who owns this data? Who can see this data? What are you doing with our data? I mean, that's kind of the industry we're in. Everybody's very worried about somebody else is going to learn from me, or my neighbor's going to know what price I'm paying, or whatever it is. This is for both of you. Ferdinand, let's start with you. Like, what happens with your data? Who owns the data? And is there any sort of negative unintended consequence of putting their data on your system?
I mean, first of all, we don't have any cost data or anything like that, so I think it's probably less critical on our end. And I mean, in general, we use the data to specifically custom design for the customer that we're working with. So first and foremost, the data is important for the specific recycler that we're working with. And of course, there's some cross-pollination with other applications. We are learning from each machine that we install. That is true. But first and foremost, we're concentrating on improving the specific process that we're working on. And it's every yard is somewhat different. Every process is a little different. So it's really custom designed for the specific application, and not so much like one size fits all and like a common library of data.
I think for us, the client data is sequestered client by client with the right security protocols, so nobody can get in and see somebody else's information. But the client has access to all their data and down to the level that they need it. So really straightforward for us. It's just a security question, making sure the IT team sets up the protocol so that one can only see their own data.
I heard from a really large metal recycling operation just the other day that said, well, the reason why they don't like AI sortation necessarily is that their opposition is learning from them and they don't want to teach anybody. I did say, well, it's going to take you a very long time to train your model just on your own material versus plug and play and have it already learned from US downstream material. So I think data is something that everybody's really worried about, but also something that people need to kind of come to terms with and realize that, I guess, global data and data around material and what it looks like is going to be hugely, hugely beneficial in most people's operation. I want to ask the question quickly to the crowd, the audience. Has anybody got a question? Because I'm going to be weary of time. We still have questions. If anybody's got a question, can you put your hand up? All right, let's just delve into some of the questions and see. I don't want to not give you the opportunity to ask.
Thanks for taking the time. I've got a question. Most of what you've talked about is MSW diversion of what could be recyclable products from landfill. The goal being landfill diversion, and it kind of depends on what your goal is. I'm responsible for operating a commingled recycling processing facility up in Portland, Oregon. We're working under the ReMA. We've got all kinds of interesting rules to play with. One of them is the living wage is coming up. So we are looking to reduce labor wherever possible. The application that we played with most recently, we had a robot operator that does a similar, it's one of your competitors, and we're trying to pull specific things from a stream. We're not trying to recover recoverables from a waste stream. We're trying to get it to sort. It failed miserably. it misidentified, it made mixed product. If what it's pulling out isn't truly that product and it has to be sorted again, it's a fail in our interpretation. Can you address anything AMP has done to solve that problem?
So I think it comes down to having a visibility of what the individual items are and writing out the spec of what you want to sort. And then running that through our lab in Denver would be the easiest way to say, hey, we have a sample, whether it's a couple gaylords of material, and we want to target these items, and then see what the outcome is. You train the neural network to pick out the things you want to target, and then be able to see what you actually achieved in targeting, and tweaking the neural network on what you missed or what you got that you didn't want to. And so you fix those errors and you tune the neural network in. It's sort of like, I'll use my old FM radio when I had to hit the dial and I needed to get to a certain point, and I'd have to really fine tune it. That's really how the AI will work. Out of the box, it works pretty well. You tell it what to target, but then when it sees the real material, you got to dial it in another level or two. And so I think those are the cases around seeing something on a conveyor moving pretty quickly, but targeting those things that you want, and identifying through quality control what you missed or what you gained that you didn't want. Yeah, I think we've gotten the robots we found have a certain quality to it, but it's not really at scale. And now getting to 5,000 picks a minute is something that's completely different for us. We've exited the new robot. We sold one new robot last year, one new robot this year to somebody in Italy, but we don't want to sell robots anymore. We're really in the facility side level at this point. And just identifying what the mistakes are and retraining the neural network. It's keystrokes. It's not anything other than that.
I'm just checking. Are you asking a question or are you just going to sit down? Okay. Okay, cool. No problem. Sorry. So I've got two questions quickly to finish off. If you were an owner operator right now of a medium-sized shredding operation or recycling facility, what is the first automation investment you would make right now and why? So you, John.
So the hard part is if I'm already operating one, it's not like I'm going to go, especially if I bought it in the past 5 or 10 years, I'm not going to just go automate it. Mm-hmm. And so my recommendation in those cases would, we have some capital already in play, optimized through other things I could buy off a shelf. It's not going to be AMP. And so like I'm a fit person. Like I don't think everybody, I might want to pick up, you might not want to pick up, you might want a taco. And so things fit for us. So I think in the case, if I already have an existing facility and want to optimize it, I'm going to look for companies like Binder+Co and others to say, all right, I'm going to bolt on something that's going to improve my operation. If I'm at my end of my life, I'm going to say, all right, well, I'm going to go look at various applications to say which one fits for me. Could be AMP, it could be something else. So my suggestion would be is the world is our oyster, and we have to make a choice based upon what our situation is.
Ferdinand?
Yeah, I think we touched on the subject earlier, and so I think my answer would be like if you're talking about somebody who has a shredder and is making sorber right now, wants to look in upgrading its material to get premium pricing for other materials, going into taking the copper out of the sorber, producing twitch, doing cast and rod sorting. I think the AI sorting is the natural next step. I mean, the conventional approach would be then to add in either a heavy media plant, add in sophisticated XRF, XRT, lip sorting with a very high sticker price. So I think that's the big advantage that the AI technology can offer you, that you're talking about a fraction of the cost, and you can make a big step, create most of the products that you can also create with this much more expensive machinery.
No more question. I got one last question. In the next 5 years, what does the winning facility look like? What have they done to get them there? Start with you, Ferdinand.
Yeah, I would say definitely incorporate more AI, more data, more flexibility. Know what you're doing, where you're good at it, where you want to go, and then utilizing the tools that are out there, that are available today, and that are getting better almost each day.
Mm-hmm.
I think the market opportunities, what changes in the next 5 years in the world around us that we can't control, and then saying, well, what's my current feedstock? Where do I want to go with my feedstock, and what I'm going to do with the various offtakes, and then design my plants around that. And so it's figuring out like what the world's going to change and how I want to change with it and within it, and find the parts or whole that fits me best.
In my companies, I like to look 5 years and say, where do I want to be? And just think of a crazy, crazy goal and work my way backwards. And then it kind of gives me a stepping stone of what I need to do tomorrow, right? And where we need to start. But what's actually insane, for 28 years, I've always been doing that. Now you can plan something crazy for 5 years, and it's actually become more realistic because of the advancement of AI and how quickly we're moving. You know, whatever you're dreaming for in 5 years, work back from there, start tomorrow. And I believe you can actually make it happen in 5 years. John, Ferdinand, thanks so much for joining us today. Really enjoyed the talk. Thank you, guys.